Welcome. On today's episode, we'll be considering real and apparent depth under refraction of light waves. It is observed that the bottom of a clear river or swimming pool always appears shallower than it actually is. This depth, as it appears to the eye, is called apparent depth. The actual depth of the river or glass block is called real depth. Now, by definition, what is apparent depth? It is the depth of the object measured by the observer when the object and observer are in different media. The observer can be in air, the object in water, or the object through glass prism. Apparent depth is the perception of depth in an image created by a combination of the range of wavelengths visible to the human eye and the physical properties of light. Real depth refers to how far something is from the viewer, while apparent depth refers to how much the viewer can see an object. Apparent displacement, which is also called apparent shift, change in position, y, is the distance between the mark, which is the object, and the apparent point above the mark, which is the image, in line of sight of the eye, in the line of sight of the eye. So displacement is defined as a change in position of an object. That is displacement, the change in position of an object. That's why we call that apparent displacement, because the object is seen to have changed position from the bottom of the glass cup to the midpoint of the glass cup. The two media are air and water in the glass cup. Then remember, our real depth is from the bottom of the cup to the tip of the water. The highest point of the water is the real depth. Then you can see your object at the bottom of the water. The image is being seen at the midpoint of the glass cup by the observer, and then that gives us apparent depth. Then we have the apparent displacement. Real depth negative apparent depth will give you apparent displacement as seen from the diagram. From the diagram, the triune components of the refractive index of glass or water as a media is the real depth, uppercase D, apparent depth, lowercase d, apparent displacement, lowercase y. Now, mathematically, we have D, which is the real depth, is equal to apparent depth plus apparent displacement. Now, apparent displacement is the of the formula. You have real depth negative apparent depth gives apparent displacement. Then refractive index then becomes real depth divided by apparent depth. Refractive index is the yardstick to determine how the light ray is able to bend, the value, the level at which the light ray is able to bend is refractive index, which is D uppercase divided by D lowercase. By substitution, D plus Y is real depth. It becomes D plus Y divided by D, which is refractive index of either the glass prism or the water. Application: the depth of a swimming pool appears to be lesser or shallower than it actually is. So it appears to be shallower than its actual depth. Is one of the applications of real and apparent depth. Number 2, apparent bending of a stick partially immersed in water. Partially, a stick partially dipped in water at an angle appears bent towards the surface of water. If the stick is vertically dipped, it appears shorter. That's it. The third, bringing objects into view. When a piece of coin, let's say the ball that is thrown into the cup, is placed in a bowl such that an observer from the side cannot see it, the ball or the coin is made visible to the observer by pouring water on the cup to a certain level, and by refraction, the observer sees it. Real and apparent. Connect to our social media handles at Physics Bible, the Triune Physics, for latest update. Thanks for joining us. Stay equipped. Stay liquid.